All right. So when it comes to your circle geometry, there is some terminology which you are supposed to be familiar with. Okay, some of the terminology you've never heard about it, but you are going to hear about it for the first time. So first we have to start with the radius, which you are common with. Okay, the radius is just the distance from the center of a circle to the circumference. Okay, the perimeter of a circle is called the circumference. Okay, so the distance from the center of a circle to the circumference is called the radius. Now, if you multiply that radius by 2, you get what's called the diameter. Okay, the diameter is actually what's called a chord. Okay, it's the longest chord which divides the circle into 2 sectors. Okay, so your diameter is equal to 2 times the radius. Okay, your diameter is 2 times the radius. Your radius is just half of the diameter. Then you have got what's called a tangent. Now, a tangent is a straight line which touches the circle only at one point. Okay, it touches the circle only at one point. So it can be any point along the circumference of that circle, but it has to touch the circle only at one point. It's a straight line. Okay, so you've got a tangent there. Now you are going to encounter that word tangent a lot. In actual fact, there's a theorem on it. There's also a theorem on the diameter, a theorem on the radius. Then we have what's called a chord. Now, a chord is just a straight line which connects 2 points on the circumference. Okay? So if I draw a line from this point of the circumference all the way up to that point, this line is called a chord. Please, when you draw the line, it mustn't go beyond the circumference. The moment it goes beyond the circumference, it's no longer a chord. Okay? So a chord is a straight line which joins 2 points on the circumference. Right? We also have a lot of talk about, we are going to talk a lot about what a chord is. Okay, in fact, we are going to talk about theorems involving chords. Then we have got what's called a segment. Now, a segment is just a small area of a circle. Okay, so if you draw any chord, the chord will divide the circle into 2 segments. Sometimes you can have what's called a minor segment, like in this case, this area here is called a minor segment because it's smaller than the bigger one. Okay, the bigger one is called a major segment. So we've got a minor segment, and then we've got a major segment, then we have got a minor segment. So any chord divides the circle into 2 segments. Now the diameter is the longest chord. It divides the circle into 2 equal segments. Then you can also have what's called a sector. Now a sector is just an area between the circumference and 2 radii. By the way, the plural for radius, okay, the plural for radius is radii. It's like that. That's the plural for the word radius. Okay? And then you have got what's called a secant. Now, if you draw a straight line which passes through the circumference of the circle and it goes beyond the circumference, we call it a secant. Now, this one is not very important, so I'm not going to worry much about it. Right? A secant is not that important. What's the line which is more important, or lines that are more important? They are the radius, a chord, a diameter, and a tangent. Those 4 are very, very important. Okay. Then obviously with your sector, you can have a minor sector. Like in this case, this is a very small area. And we have got a major sector, which is the bigger one. Okay. Please be aware that a sector and a segment can be minor, it can also be major. The bigger one is called the major one. The smaller one is called the minor one. Okay. Right, so you can talk about an arc as well. Now, an arc of a circle, it refers to the distance between the end points of a chord on the circumference. Like, for example, from this point along the circumference all the way up to there. That distance there is called an arc. Okay, I'm going to repeat it. An arc is a distance on the circumference between the endpoints of a chord. So you can have this as point A and that one as point B. So here we have got chord AB. We also have arc AB. An arc is just a small part or a part of the circumference. Okay? An arc is part of the circumference. So an arc can be a minor arc. In this case, AB is a minor arc. Then you have got also AB, the bigger one, which is also a major arc. So you're going to have a minor sector, minor arc, minor segment, major arc, major segment, major sector. But the most important of all of these are your radii, or your radius, your chord, your diameter, your tangent. Okay, we are going to talk about the arc, of course, sometimes. And the center itself, the center is also very, very important. Okay, the center is also very, very important. All right, to know that your psychogeometry theorems can be classified into 3 groups. Okay, so we'll start with the first theorem. Now, the first theorem, it's a center theorem, and it is the only theorem which doesn't involve calculation of angles. Okay? The first theorem, which you can call theorem 1, is the only theorem which involves the calculation of distances, but it doesn't involve the calculation of angles. Of course, later on you might find a question which also incorporates angles, but theorem 1 on its own doesn't involve any calculation of angles. Okay, please just put your pens down for a while. Now, according to theorem 1, if a line is drawn from the center of a circle, okay, if it's perpendicular to a chord, it will bisect a chord. Okay? Just to clarify this. So a line drawn from the center of a circle, perpendicular to a chord, bisects the chord. So it's like this. If I draw a circle, if I've got a center here, and I've got a chord, maybe you can call this AB, okay? As long as I draw a line which passes through the center, or which originates from the center, if I draw a line which is perpendicular to that chord, that line will bisect that chord. Okay? Please take note here that there are 2 conditions for the line to bisect the chord. The first one is that it has to pass through the center, or it has to originate from the center. Also, it has to be perpendicular to the chord, because you can draw a line passing through the center like this, and it won't bisect the what? The chord. It will pass through the center, yes, or it may not. It may originate from the center, but if the line is not perpendicular to the chord, then it won't bisect the chord. So any line which is drawn from the center of a circle perpendicular to a chord bisects the chord. Right? Now, according to the acceptable reasons that I gave you, right, the shortcut form is line from center perpendicular to chord. This is the acceptable reasons which you see on the worksheet. Can you go to circles there? Go to circles of your acceptable reasons. Okay, your acceptable reasons are classified into groups. So you have got lines, which is mainly grade 8 and 9 and 10. Then you have got triangles, which covers all the way up to metric, by the way. Okay, but for now it was mainly grade 8 and 9 and 10. Then you skip grade 11 because in grade 11 we focus more on circles. But your triangle geometry, you did that from grade 8 to 10. Triangles will continue next year as well. So where we are is the group on circles, right? So if you go down, okay, it will be the 4th line, okay? The 4th line. The line drawn from the center of a circle, okay, perpendicular to a chord, bisects the chord. And as you can see, the shortcut for the acceptable reasons, it's line from center, then you put the perpendicular sign to chord. Okay, so whenever I use this theorem here, this is the acceptable reasoning that you are supposed to use to make things easier for yourself. Right? Now, the proof of this theorem is one of 4 proofs in grade 11 that is examinable. In actual fact, it came last year in the metric examination. So the proof of the theorem is examinable. Okay? Now, if you want to do the proof, you need a bit of some knowledge of congruency. Remember I did congruency, the 4 conditions of congruency. What are the 4 conditions? You have RHS, triple S, SAS, and you also have what? Angle side. Okay? So you have got RHS, triple S, SAS, and then you have got angle side. Those are the 4 conditions. Okay? The 4 conditions of congruency: RHS, SAS, then you have got triple S, and then you have got double AS. Right? Or you can say angle side angle, whichever the case for double AS. Right? Now, if you want to do the proof, can you put your pens down, please? So, first, the condition is that you'll be given a line which bisects a chord. So, let's call this center here M. Okay, we're going to represent that center by the capital letter M. Okay? So, according to theorem 1, OM, okay, so, I'll call this the center O, that's from there, and then this point here, where the line bisects with the chord, I'll call it point M, and that will be point M. So, OM must be perpendicular to AB. If OM is perpendicular to AB, it therefore means that AM is going to be equal to MB, or it means that the chord AB is bisected. Okay? So we need to prove that. Now, if you want to do the proof, this proof is examinable. Okay? It means it can come in examinations. You can be asked to prove the theorem. So if you want to do the proof, first you have to do a construction. So you must join the center, which is O, to point A. If you do that, you end up having this radii here, or this radius. That's that OA. You also join point O to point B, and then you create a second radius, or you can call it radii if you want, so that you end up having OA being equal to OB, okay, because they are radii. So, from your knowledge of congruency, obviously, if you want to prove congruency, use any one of these 4 conditions. Now, with this theorem, we are not worried about triple S, double AS, or angle side angle, and SAS. We are going to do the proof using RHS, because we are going to have a right-angled triangle. Okay, so once you join the center to those 2 points on the circumference, you create 2 radii. So, when you want to do the proof using congruency, the first point is to say OA is equal to OB because they are radii of a circle. All radii of any circle are equal. Then, at M, you can name the 2 angles there. The one on the left of OM can call it M1, the one on the right can call it what? M2. But you need to be aware that you will be given that OM is perpendicular to AB, which means M1 and M2, they will both be equal to 90 degrees. So M1 will be equal to M2, they are both equal to 90 degrees. This will be given. How do I know that it's given? It's because of this word. Okay? A line drawn from the center of a circle perpendicular to a chord bisects the chord. So you'll be told that the line is perpendicular according to this theory. Since the line is perpendicular to a chord, it means the angle, the 2 angles that are along AB, they will be 90 each. Now, since the first one, I'm sure you can agree with me that in triangle AOM, OA is going to be the hypotenuse because this angle is 90 the side opposite the right angle is the hypotenuse. So you're going to have your hypotenuse, then your right angle there. So what's left is just any side. Okay? So the other side now is going to be OM, because OM is a common side to both triangles. Remember, our two triangles here are OAM and OBM. So we are going to have a common side, and that common side will represent our sides in the acronym RHS. So you're going to have your right angle, your hypotenuse, and your side. Once you do that, then you conclude that therefore triangle OAM and triangle OBM are congruent. Right? Now, if you remember from the past, that is your grade 8 up to 10, what does it mean to say that two triangles are congruent? Huh? They are the same. In what way are they the same? The corresponding sides are what? Are equal. Also, the corresponding angles are equal. Furthermore, the areas of those triangles are also equal. Remember, if the sides are equal, the corresponding sides are equal, the angles are equal, it therefore means the areas of the two triangles are also what? Are also equal. So, triangle OAM and triangle OBM are congruent, and the condition is going to be the RHS condition. Once you prove that congruency, you can now say, therefore, AM is equal to NB, because this is what you are supposed to prove in the end. You are supposed to prove that the chord is bisected by the line which passes through the center or which originates from the center, and that line is perpendicular to the chord. Alright? So this is where you're supposed to go. Please take note of what I indicated here. This proof can come in examination. Right? So you can expect it in your June exam, your November examination. Okay, it can come. Right? Is there anybody who has got a question? Okay. In actual fact, there are about two of them, two convex, but this is the main one. Okay, so here I gave you a definition of what the convex is, just to help you to understand what the word convex is. So a convex is just a statement which is the reverse of another, or the reverse of what already has been what? Proven. Okay, so when you say convex, you are referring to the opposite. Okay. Now, the converse of theorem 1 says a line segment joining the center of a circle to the midpoint of a chord is perpendicular to the chord. Now, it's the opposite of the original theorem. Remember, with the original theorem, you will be told that, okay, in this case we had OM, which was perpendicular to AB, and this means that AM will be equal to MB. Okay, this is the original theorem. Can you pay attention? You see, it's better to write something with understanding. Okay? Don't just copy it down. Okay.